Very good afternoon to all and welcome to my class. Today we are going to discuss the organic compounds containing nitrogen group, right? So, we already covered till that is the organic compound containing halogen, oxygen, that is alcohol, phenol, ether, and also cover aldehyde, ketone, carboxylic acid. So, today we are going to cover the organic compound containing nitrogen only, right? So, let's see what we are going to discuss in this class. So basically, if I'm talking about, okay, so how will you classify amines, right? So amines are the derivative of ammonia, as we know that this is nothing but amine, that is RNH2. So how this will form? So we know that this is ammonia, that is NH3. So when you replace one H, one H with the R, then we'll get this ammonia. So amines. So amines are the derivative of ammonia in which one or more hydrogen atom are replaced by alkyl or we say aryl group. Amines are classified into the three different types as a primary, secondary, and tertiary, depending upon the number of hydrogen atom replaced by alkyl or the aryl group, right? So these amines are classified into the three types: primary amine, secondary amine, and the tertiary amine, depending upon the number of hydrogen atom replaced by alkyl or we say aryl group. So this is the here only one hydrogen is replaced by one alkyl group. So this is termed as the primary amine. Here two hydrogen is replaced by the two alkyl groups, so known as the secondary amine. And here the three hydrogen is replaced by the three alkyl groups, so it is known as a tertiary amine. So this is the primary amine, right? This is the secondary amine, and this is nothing but tertiary amine. So this is the primary, secondary, and the tertiary amine, right? So this is how we can classify the amines into the primary, secondary, and the tertiary. Now, if four alkyl group are attached to the nitrogen atom, then the quaternary ammonium ion or salt is formed. So if the four alkyl group are attached to the nitrogen atom, then the quaternary or ammonium ion or salt is also formed. For example, here you can replace all three hydrogen with the three alkyl group, and one lone pair is also replaced by this R group. So are known as a quaternary ammonium salt, right? So this will form. Now, what is the structure of amine? So the nitrogen atom of amine is approximately sp3 hybridized. So if I'm talking about the hybridization, right? If I'm talking about the hybridization of the amine, so the nitrogen atom of the amine, that is RNH2, is sp3 hybridized. Now, the three alkyl group or hydrogen atom occupy the three corner of the tetrahedron, while the unshared pair of electron is directed towards the other corner of the tetrahedron. Right. So this is the structure in case of this. Now, if we consider the three group attached to the nitrogen as R1, R2, and R3, then the shape of the molecule can be described as trigonal pyramidal, right? As we can see that this shape is known as a trigonal pyramidal. If three alkyl groups are present and one lone pair is present. So these three group could be either alkyl group or the hydrogen atom. They form trigonal pyramidal. Accordingly, the amine is called primary, secondary, and the tertiary amine. So here in case of primary amine, this is in case of secondary, this is tertiary. So the structure of amine, or we can say that the shape of the molecule can be described as the trigonal pyramidal, either while taking three alkyl group or three hydrogen group, right? So these three and having sp3 hybridization. However, if you consider the lone pair of electron also as a group attached to the nitrogen, then the geometry of the molecule is called the tetrahedron, right? So if you consider the lone pair of electron also as a group attached to the nitrogen, then the geometry of the molecule is called tetrahedron. So the bond angle between R and R are close to the tetrahedral angle, that is 109.5 degree. Right, Rn and R are close to the tetrahedral angle 109.5 degree. The amino group in aromatic amine is directly bonded to the benzene ring, right? And the aromatic amine are a right derivative of the ammonia, also known as the aniline. So the parent aromatic amine is known as aniline. So remember this thing, the parent aromatic amine is known as aniline. Now, these are the IUPAC nomenclature of the amine, that how will you write. So this is the simple example where the CH3NH2. So we can write as there is only one carbon is there. So we can write as methane and NH2, that is methane amine. So it is a common name here. So common name is methylamine and IUPAC name is nothing but methanamine, right? Here also CH3, CH2, NH2. So we can write if two carbon that known as ethanamine. Here also 1, 2, 3, that is propane 1 amine, right? So this is known as propane 1 amine. Now here we can say that CH3, CH, CH2, NH3. So that is the numbering. How will you do the numbering? That is nothing but this is 1, this is 2, and this is 3. So that is 2 methyl propane 1 amine. And this is also known as a benzylamine or the commonly known as aniline. So this is what we basically know as common name, that is the aniline. So I hope this is very much clear to you. That is how will you write the name of the 1 degree aliphatic amine, or we say aromatic amine. Now let's see the how will you write the name of the second degree amine. So here the amine is second degree. So always remember one important note here for writing the name IUPAC name. Always identify the smaller group. The smaller group act as a, for example, in amine, right? So this is known as this is CH3 and CH3. So this is the secondary amine. As we know that there is a two alkyl group attached to this nitrogen atom. So this is definitely secondary amine, right? This is secondary amine. So this is the secondary amine. So IUPAC name is nothing but N-methyl ethane amine, right? N-methyl ethane amine. So we can write as N-methyl, and this is N-methyl and methane amine. So always take a smaller group. For example, in this example, this will get cleared. For example, in this N, this alkyl group having two carbon atom and this alkyl group only one carbon atom. So always state the smaller group as a N alkyl, right? So this is N and one carbon there now. So this is N methyl, right? This is only N methyl. Remember this thing. So this is N methyl. Always remember. So N methyl, and this is what? That is ethane amine. So that is N methyl ethane amine. Right. So N methyl ethane amine, and common name is ethyl methyl amine. So always try to learn the IUPAC name only because they have a specific rule so that we can remember this name. Now, in case we have one smaller group is here and one smaller group is also here. Right. So this will be known as N-ethyl N-methyl. So this is known as N-ethyl, right? And this is again N-methyl, and this is propane 1 amine, right? This is propane 1 amine, 1, 2, 3. So this is propane 1 amine. So N-ethyl N-methyl propane 1 amine. Now, these are the common of the aromatic name, right? Let's see them. So these are known as 2-chloroaniline, or also known as orthochloroaniline. This is para-nitroaniline, orthochloroaniline, para-nitroaniline, and this is known as orthotoluidine. Right, this is known as the orthotoluidine. So this is the name of this, right? This is known as the orthotoluidine. So this is the IUPAC name of the following orthochloroaniline, para-nitroaniline, and this is orthotoluidine. Right. So let's see some preparation of a amine, that how will you prepare amine from the following, right? How will you prepare the amine? So first of all, we'll prepare amine from alkyl halides, right? So alkyl halides react with ammonia to form primary amine. Okay. So alkyl halides react with ammonia to form primary amine. For example, RX, this react plus 2NH3. So this RX react with 2NH3. So form RNH2 plus ammonium salt, right? So alkyl halides react with ammonia to form primary amine. The primary amine so formed may further react to give a secondary amine, tertiary amine, or we say a quaternary ammonium salt. So the primary amine so formed may further react to give the secondary amine, tertiary amine, or we say quaternary ammonium salt. So in order to get the good yield of primary amine, the reaction carried out using the excess of ammonia. Always remember this. If the excess of alkyl halide are there, then we'll want to get the only primary halide. You'll get the mixture of the primary, secondary, tertiary, and even quaternary halide. Right. So the primary amines so formed may further react to give secondary amine, tertiary amine, the quaternary. So in order to get the good yield of the primary amine only, the reaction is carried out using a excess of ammonia. For example, bromoethane on a reaction with the excess of ammonia, that is 2NH3, give methanamine. Ethanamine, sorry, like C2H5NH2 NH4Br, right? So this is how will you get this. I hope this is clear to you. That is from alkyl halide. By treating alkyl halide with ammonia, how will you get the primary amine, right? Now, let's move to the next method, that is by the reduction of the nitriles, or we say cyanides, amides, and nitro compounds, right? So by the reduction of nitriles, also known as a cyanide, or we say amide and the nitro compound, we also obtain this. So the compound containing the cyano, that is the amido, or the nitro group can be reduced into the corresponding primary amine. How? So the compounds containing cyano, amido, or nitro group can be reduced into the corresponding primary amine. Nitriles can be reduced by hydrogen in the presence of platinum catalyst or by the sodium in presence of ethanol to corresponding primary amine, right? So nitriles can be reduced by the hydrogen in presence of platinum. For example, propane nitrile, that is a cyanoethane, on reduction give propane 1 amine, right? For example, propane nitrile, that is cyanoethane, on a reduction give propane 1 amine, that is CH3, TH2Cl, propane 1 nitride. And if you treat this with the sodium and the ethanol or the reduction S2P2, then we'll get the propane 1 amine. So this is how we do prepare from the propane nitrile to propane 1 amine. Now, similarly, amide are reduced by LiLH4 to the primary amine, having same number of carbon atom as in starting amide, right? So similarly, amide are reduced by LiLH4 to the primary amines, having same number of carbon atom as in the starting amide. For example, ethanamide give the ethanamide on reduction, right? Ethanamide give ethanamine on reaction. For example, here we have a CH3CONH2. When the reduction takes place in the presence of LLH4, it will give ethanamide. So ethanamide react with LLH4 to give the ethanamide. Similarly, reduction of the nitro compound can be carried out by using hydrochloric acid and the metals such as the tin and the iron, right? So they can also be reduced with the hydrogen in presence of nickel or platinum act as a catalyst. Such reduction of nitrobenzene by any of these methods provide aniline. So whenever nitrobenzene and you treat the nitrobenzene either with the nickel, platinum as a catalyst, or we say SN or SCl, you will get the aniline. So the reduction of nitrobenzene always gives us aniline. Remember this thing. Now, this one is very, very, very important method. That is by Hofmann's bromide reaction. So basically, aliphatic amide on treatment with the bromine and strong base like NaOH, potassium hydroxide, are converted into the primary amine having one carbon less than those parent in the starting amide, right? So aliphatic amides on treatment with bromine and a strong base like a potassium hydroxide are converted into primary amines having one carbon less than those of present in the starting amide, right? For example, this is amide RCONH2. When they are treated with the Br2 and 4KOH, they will convert into RNH2, that is amide, plus K2CO3, that is potassium carbonate is the byproduct, and 2KBr and H2, right? Thus, ethanamide is obtained by treating propane amide with the bromide and KOH, right? So we can also obtain ethanamide when the treated with the propanamide. So always remember here we'll get the amine with the one carbon atom is less. So always remember this thing. When you take propanamide, then you will get ethanamide. When you take butanamide, then you will get propanamide. When you take propane amide, you'll get ethanamide. So this is how this is, right? So here we have a propanamide, then react with the Br2 and KOS, it will give us the ethanamide plus 2 KPR plus K2CO3 and H2. Okay, so what are the method of preparation of the amine. So let's quickly revise. The first method for the preparation is from the alkyl halide. So by treating alkyl halide with the NH3. So by treating alkyl halide with ammonia, we'll get this. Similarly, when you treat by the reduction of nitrile cyanides, we can also say amides and nitro compounds. So this is also we can prepare a nitro compound. Next is by the Hopkins bromide reaction. So these are the method of preparation of the amine. Right. This is how we'll prepare amine. Now let's see the some physical properties of the amine compound. So first of all, aliphatic amine containing up to three carbon atoms are gaseous, whereas the higher amines are liquid, right? So the aliphatic amine containing up to three carbon atoms are gaseous, whereas higher amines are liquid. Some higher aromatic amines are even solid, like methyl and ethyl amine have a smell like ammonia. So just remember this thing, the aliphatic amine containing up to the three carbon like methane amine, ethane amine, or we say propane amine, up to three carbon atom only, are the gaseous, where higher amines are liquid. Some higher aromatic amine are even solid, right? So methyl and ethyl amine have smell like ammonia. So amine have a higher boiling point than corresponding hydrocarbon because of the hydrogen bond amongst themselves, right? Lower amine are soluble in water and the solubility decrease with the increase in the size of the alkyl group. This solubility is because of the presence of hydrogen bonding between the amino group and the water molecule. All amine are soluble in the organic solvent like benzene, alcohol, ether, etc. Right? So they are soluble in organic solvent. Now, let's see the chemical properties of amine. So, what are the chemical properties of amine here, beta? So, basically, if I'm talking about the chemical properties of amine, we have to study the basic characters. That is what is the basic character. For example, amine are basic in nature. Why amine are basic in nature? It is basically due to the presence of lone pair of electron on nitrogen. So due to the presence of lone pair of electron on the nitrogen, amine behave like a basic, right? How this lone pair look like? For example, we know the formula of amine is this RNH2. So we all know that nitrogen having 5 valence electron. So out of 5 valence electron, 2 electrons takes place in sharing with hydrogen, 1 electron with this alkyl group. So 3 electrons, so 2 electron, which is act as a lone pair. So this lone pair. So amine are basic in nature due to presence of a lone pair of electron on the nitrogen. So this lone pair has a strong tendency to, nitrogen having a strong tendency to give this lone pair. Thus, they behave like a basic in nature. So amine are basic in nature due to the presence of lone pair of electrons. Now you know that the strength of the base depends upon the availability of the electron. If the availability of electron is very easy, if the more number of electrons available, it behave like a strong base. So basicity of amine can be compared with respect to ammonia by comparing the availability of the pair of electrons on the nitrogen. Now, if I am considering about RNH2, that is the primary amine, and if I'm considering that is ammonia, so out of these, which two having more basic in nature? Because in all this, ammonia and amine both having one lone pair of electron. So both have a tendency to donate this lone pair. But in which case the lone pair donation is easy. So we can observe here that in case of primary amine, this is in case of amine, one donor group is also present, like alkyl group. So in this, nitrogen can easily donate their lone pair of electron, right? They can easily donate. So they can easily donate their lone pair of electrons. How? Because because in this one alkyl group is present which acts as an electron donating group. Where in case of ammonia, ammonia also have a tendency to donate the lone pair of electron, but not such as amine. Because like amine, they do not have any lone pair of electron. Right. Sorry, they do not having alkyl group attached to it. So they having less tendency as compared to the primary. Okay, so ammonia and amine both when dissolved in water, they attract a proton from water to form a ammonium or alkyl ammonium respectively and hydroxide. And let's see this. So when the NH3, when this NH3, right, this, let me write this. When this NH3 is treated with water, this will form NH4 plus, that is ammonium ion, right? This will form the ammonium ion and OH negative. Similarly, when the amine is treated with the water, it form alkyl ammonium amine. Since alkyl group are electron releasing group, as we already discussed, electron donating group, they increase the electron density on the nitrogen. This makes the lone pair of electron on nitrogen atom to be easily available for the sharing, and hence this increase the basicity of amine, right? So, since alkyl group are electron releasing group, they increase the electron density on the nitrogen, and this make the lone pair of electron on the nitrogen atom to be easily available for the sharing. Hence, this increase the basicity of the amine. So we expect that the basicity of amine would be increased as we move from primary to secondary to the tertiary, right? Because in tertiary amine we have a more donor group. Similarly, in the secondary amine we also have a more donor group as compared to the primary. So the basicity increase as we move like this, right? So I hope this is clear to you, right? Hmm. So this make this. So we expect that the basicity of amine would be increased as we move from primary to secondary to the tertiary. Just wait for 2 minutes. right? So since as the alkyl group increase, so we expect that the basicity of amine would be increased as we move from primary to secondary to the tertiary amine, right? Let's see. But the order of basicity has been found to be that is secondary amine, right? That is the secondary amine having more basic as compared to primary and tertiary as well. So the tertiary amine are less basic than the secondary amine. What is the reason? The secondary having more than primary, this is clear. This having no problem because the more number of alkyl group are present, then their basis it will be more. This will be very much clear. But why the secondary amine, or we say the tertiary amine, are less basic than the secondary amine? So the reason is that tertiary amine through has a three alkyl group which can donate electron to the nitrogen atom, but they also cause crowding, also no called steric hindrance around the nitrogen. This hinders the protonation at nitrogen atom and hence reduces the basicity. So the aromatic amines, if I'm considering, if I am compare amine with the aromatic amine, so the aromatic amines are weaker base than ammonia because the aromatic ring is electron withdrawing, right? So the aromatic amine are the weaker base than ammonia because of the aromatic ring is electron withdrawing. It reduces the electron density at the nitrogen and makes the aromatic amine less basic. So we can express the basic character of aliphatic and aromatic amine. That is, aliphatic amine having more basic character as compared to ammonia, and ammonia having more basic character as compared to the aromatic amine. So aromatic amine are expected to be show less basic character, right? Now let's see the second chemical properties that is called alkylation. So basically, primary amine react with alkyl halide, right? So the primary amine react with alkyl halide to give, secondary amines. Okay. So the primary amine react with alkyl halide to give secondary amine. The reaction may continue further to form a tertiary amine and a quaternary ammonium salt. For example, the reaction of ethanamine and bromoethane proceed as shown below. For example, here, if we treat CH3CH2 NH2 with the CH3Br, right? So when the ethanamine that is treated with the bromoethane, this is the reaction of alkyl amine with the alkyl halide. So when you treat CH3CH2 NH2 with the CH3Br bromoethane, you'll get N-methyl ethanamine. This is the secondary. Now, the one further they react with CH3Br to form N-dimethyl ethanamine. Similarly, they react with the CH3Br again to form ethyl trimethyl ammonium bromide. So these are the three sequence, right? When the ethanamine is treated with the bromine ethane, it will convert it into N-methyl ethanamine. Similarly, when the N-methyl ethanamine is treated with the CH3Br, they will form an N-dimethyl ethanamine. And when they're treated with the CH3Br, they will form ethyl trimethyl ammonium bromide. So this is how the reaction proceeds. Right. Now, on the similar basis, let's discuss about the acylation, that what is happening in acylation. So if I'm talking about the acylation, the primary amines on reaction with the acid chloride like CH3COCl or maybe acid anhydride, they give unsubstituted amide, right? So remember this point. When the primary amine on reaction with the acid chloride and anhydride, they give N-substituted amide. For example, here we can see that this is a primary amine, right? So when this primary amine is treated with the acid chloride, that is RCOCl, the formation of R substituted amide will be takes place like RNH, and this will form C ONR. So HCl is removed. This C will be joined here, right? So the formation of substituted amide will be takes place. For example, aniline on reaction with ethanoyl chloride, this is acetyl chloride, CH3COCl, also known as ethanoyl chloride, give acetanilide, right? This will give acetanilide. For example, here we can say that aniline and react with the ethynyl chloride, so they will give NH, right? And this is COCH3. Right, COCH3. So they will get acetyl Next is that is the carbonamide reaction. So when the primary amine is heated with the chloroform in presence chloroform in a compound, the presence of alcoholic potassium hydroxide, then the corresponding isocyanate is formed. Remember this. Only primary amine give this test, right? So when the primary amine is heated with the chloroform in compounds, the presence of alcoholic potassium hydroxide. So when the primary amine is heated with the chloroform and in presence of alcoholic potassium hydroxide, then corresponding isocyanate is formed. Isocyanate is also known as a carbolamine, hence the reaction is called as a carbolamine reaction. For example, aminoethane undergo this reaction give ethyl carbolamine. For example, this is CH3, CH2, NH2. This is the primary amine. When they are treated with the chloroform, CHCl3 and KOH, and they are heated, they will form ethyl carbolamine, right? So isocyanate give a very offensive odor. So this reaction is also used as a test for the primary amine. So if you want to distinguish between the primary, secondary, and the tertiary amine, then you can use this test, right? Because only primary amine can give this test, right? Right? So only primary amine can give this test. So isocyanate give a very offensive odor, very uh, uh, offensive odor means a very not pleasant type of that is just unpleasant odor. So this reaction is also used as a test for the primary. Now next is very important, that is the reaction with the nitrous acid, right? So let's see what happened when the amine is treated with the nitrous acid. So the primary aromatic amine react with the nitrous acid to give disonium salt, and this reaction is known as disonation. So remember this point, that primary aromatic amine react with the nitrous acid to give disonium salt, and the reaction is known as disonation. Nitrous acid is an unstable compound and cannot be stored. So it is prepared during the reaction by mixing sodium nitrate and hydrochloric acid. So this nitrous acid is an unstable compound and cannot be stored. So it is prepared during the reaction by mixing sodium nitrate and hydrochloric acid. The reaction is specifically carried out at a low temperature between 273 to 278 Kelvin. For example, aniline react with the nitrous acid to give benzene disonium chloride, right? Like aniline react with the nitrous acid to give the benzene disonium chloride. So let's see here, when the aniline is treated with the NaNO2 HCl in presence of 273 to 278 Kelvin, it will give BDC, that is benzene disonium chloride or disonium salt. Now, primary aliphatic amine also react in the similar way, but the disonium salt formed are unstable and decompose to give alcohol and the nitrogen gas. So here also the N2Cl, that is the ethyl disonium chloride, that is the unstable disonium salt is formed, but they are highly unstable and directly react with water and decompose to give alcohol and ethanol. So thus ethane amine gives ethanol when subjected to this reaction. Now, primary amines also undergo condensation reaction with aldehyde or ketones to form imine. So this one is also very important. That is, the primary amine undergo condensation with the aldehyde or ketone to form imine. What is imine? Carbon nitrogen double bond is known as also as imine. These products are also called skiff bases. Skiff bases, right? So the reaction can be shown below. For example, we have R dash CO R R. They react with H2 and R and amine to form a skiff base like R dash, R double dash, and NR. So they will form skiff bases, right? So these are the primary amine, all about the primary. Now the ring substitution in the aromatic amine. So this is going to be very important. We all know that the NH2 group is a strong activating and orthopara directing group for the electrophilic aromatic substitution reaction, right? So you know that NH2 group is a strong activating and orthopara directing group for electrophilic aromatic substitution reaction. This directive influence can be explained by the following resonating structure of the aniline. For example, we have an aniline, NH2. So we know that aniline having lone pair of electrons, so they having tendency to donate this lone pair of electron to this. When they donate this electron is substituted there. So we can observe that in all ortho, para, and ortho, right? Ortho para position, we have a maximum electron density, right? So we can say that what we can say that from this we can say that aniline having ortho-para directing group because in this NH2 group is attached to the benzene ring which is electron donating group. So this will increase the electron density at all ortho and para position. Right. So this directive influence can be explained by the following resonating structure of aniline. Right. I hope this is clear to you. Hmm? Okay. So as the result of this resonance, the electron density is more at ortho and para position. Hence, the electrophilic substitution occur at this position only. That is only at ortho and the para position. Okay. Some important ring substitution reaction of the aromatic amines are halogenation, nitration, and the sulfonation. So let's see one by one. If I'm talking about the halogenation, so basically aniline on treatment with an aqueous solution of bromine give 2,4,6 tribromine. Always remember this. Whenever the aniline is treated with the aqueous solution of no aqueous Br2, right? When the aniline is treated with the aqueous Br2 halogenation, this will give 2,4,6 tribromoaniline. This point is very, very important. Similarly, nitration, that is the nitration of aniline is carried out on the acetylamine, acetanilide, rather than on the free amine itself. So there are the two reasons for this. So nitration of aniline is carried out at the acetylated amine. Always remember, rather than on the free amine itself. Why? Because the free amine is very susceptible to oxidation and thus much of it lost in the form of black sticky material which is formed as a result of its oxidation. The free amine is very reactive, but acetyl, the group protect it and reduce its activity. So what is happening here now? First of all, you need to the nitration of aniline with the protection of the amino group as shown below. So first of all, you need to treat aniline with the acetyl, that is CH3COCl, then acetanilide is formed. After this, you have to treat with the concentrated HNO3 and H2SO4, then para-nitroacetylene and para-nitroaniline will be formed. The first step consists of the acetylation of amino group in the aniline, the conversion of NH2 to NHCOCH3, lowers the activity of NH2 group because of the electron withdrawal by the COCH3. This step is followed by the nitration, concentration HNO3 H2SO4, which give mainly the para-nitroacetanilide. This on acid hydrolysis is the desired product of para-nitroanil, right? So on hydrolysis, you'll give back to the para-nitroanilide. Now, the first consists of acetylation of this amino group in aniline. This we already covered now. Sulfonation is carried out in the presence of sulfuric acid, right? So the sulfonation is carried out in the presence of sulfuric acid. The amino group in aniline is a basic group. Therefore, an acid-base reaction takes place to form anilinium hydrogen sulfate salt. This salt undergo rearrangement at a high temperature to give the sulfanic acid. How? Let's see. So first of all, this aniline is treated with the H2SO4. This will give the aniline hydrogen sulfate, that is NH3 HSO4. Now, when they are further heated at 455 to 475 Kelvin, they will give us sulfanic acid. Right. So these are the how we'll classify them. Now we have to identification of the primary, secondary, and the tertiary amine. So let's see how will you identify the primary, secondary, and the tertiary. right? So, how will you identify the primary, secondary, and the tertiary amine? So, the primary, secondary, and tertiary amine can be distinguished from each other using the Hinsberg test, right? So, by using the Hinsberg test, we can easily, distinguish between the primary, secondary, and the tertiary amine. So, in this test, a small amount of, right, in this test, a small amount of the amine and no benzene sulfonyl chloride is shaken with the access of potassium hydroxide. After allowing the reaction to take place, the mixture is acidified, right? So after allowing the reaction to take place, the mixture is acidified. The following is observed for the different types of amine. For example, the primary amine react with the benzene sulfonyl chloride to form N-substituted benzene sulfonamide, which in turn forms water soluble potassium salt with access of potassium hydroxide, right? So the primary amine react with the benzene sulfonyl chloride to form N-substituted benzene sulfonamide, which in turn forms water soluble potassium salt with access of potassium hydroxide. So this is the one way, and that is how will you distinguish between the primary, secondary, and the tertiary amine. Let's see the reaction of each of them. For example, if I'm talking about the primary amine, so this is the primary amine and this is the Hinsberg region. That is benzene sulfonamide, right? As we already known here and known as the, benzene sulfonyl chloride. So when you treat with primary amine with the benzene sulfonyl chloride, then what will form? That is, this is the acidic hydrogen, RNH. This is the acidic hydrogen. Then again react with the KOH to form water soluble potassium salt, or we say this is a very clear solution, water insoluble sulfonamide. So primary reaction give this test. Similarly, the secondary amine react with the benzene sulfona chloride in aqueous potassium hydroxide to give insoluble NN disubstituted sulfonamide, which form a precipitate. So this sulfonamide are not soluble in aqueous KOH because they do not have an acidic hydrogen. Hence, on further acidification, also there is no change in the racemic mixture. For example, when the secondary amine is treated with the benzene sulfonyl chloride, they will give water insoluble product, right? In case of tertiary amine, if the amine is water insoluble, then no change will be takes place on addition of benzene sulfonyl chloride. Okay, right. So, however, when they acidify this mixture, the tertiary amine will dissolve in water, soluble salt will be formed. So let's see the now we already cover all the amine, that is their method of preparation, their physical properties, their IUPAC naming, their chemical properties. Now we move to the disonium salt, right? So what are the reaction and importance in the synthetic chemistry, right? So what are the disonium salt and what are the reaction and importance of disonium salt in the synthetic chemistry, right? So most of the arene disonium salt formed from the aromatic amine are unstable at a temperature above 5 to 10 degrees Celsius. This salt exploded when they dry. So important note here, most of the arene disonium salt formed from the aromatic amine are unstable at a temperature above 5 to 10 degrees Celsius. So they are always stored below this temperature. These salt explode when they dry. Therefore, many of the no, therefore many of their further reaction are carried out without isolating them. The reaction of disonium salt are very important synthetically because the disonium group can be replaced by a variety of other groups such as the fluorine, chlorine, bromine, iodine, cyanide, OH and H. So this reaction are given below as the Sandmeyer reaction. This is one of the best reaction of which of the disonium compounds, right? So in this reaction, the arene disonium salt are reacted with the copperous bromide, or we say copperous chloride, or we say copperous cyanide in presence of HBr, SCl, and SCN respectively. So this is the Sandmeyer reaction. Some of the example of the Sandmeyer reaction are given below. So you can see in this reaction that the disonium group is replaced by bromine, chlorine, and the cyano. Right. So let's see each by one, each one. So this is the first. That is when the aniline is treated with HBr in presence of NaNa2 in presence of H2 from 0 degree to 10 degrees Celsius. So the benzene disodium bromide will be formed into here. Now when they are treated with the copperous bromide, that is UBr, 100 degrees Celsius, this disonium group is replaced by the copperic bromine group. So the bromobenzene will be formed. Similarly, when the aniline is treated with the HCl and Na2, they will form N2. And here they will form N2Cl. Not Br, this will form Cl, N2Cl. Now, when this copper Cl is treated with this, then this group is removed and the formation of this will take place. Right? Similarly, when they're treated with the CN, N2CN, in the presence of copper CN, this disonium group, that is N2 is removed and the CN will be formed. So they will get cyanobench. So whenever you want to convert anything that is from aniline to whether it will be from bromobenzene, chlorobenzene or cyanobenzene, always remember this formula, right? That is aniline undergo disonation to form disonium salt. And when the disonium salt is treated with the copper Br, or we say copper chloride, or we say copper cyanide in presence of HCl, HBr, and HCN, it will form the corresponding bromobenzene, chlorobenzene, and the cyanobenzene. Right? So now let's see the replacement of disonium group by the I group. How iodine replace the disonium group. So in this reaction, the disonium salt is treated with the potassium iodide, that is Ki, to give the product in which the disonium group has been replaced by the I group, that is iodine group. So as we can see that this is N2Cl disonium, and when they are treated with the Ki, right? When they are treated with the Ki, they will convert it into I, that is the iodobenzene, right? They will convert it into iodobenzene. So this is how this will form, that is the iodobenzene and KCl, and this will gives us N2. Okay, so this is the replacement of the disonium group by the this I group. So whenever the N2Cl is treated with the Ki, then this Ki convert remove this diazo group and convert into this iodobenzene. So whenever in question they are asking how will you convert, yeah, what happened when the benzene disonium chloride is treated with Ki, always remember this. This is how we can convert this benzene disonium chloride into iodobenzene. Now the next is replacement of disonium group by minus F fluorine group. That how fluorine group can replace the disonium group. So basically the compound here, the disonium salt is first treated with the fluoroboric acid HBF4, and the disonium fluoroboric precipitate is isolated and dry. So it is then heated until it start decomposing to give the aryl fluoride product. So this reaction is also very important and known as this is also known as a Glass-Hechimans reaction, right? So how this reaction takes place? So basically, compound here, the disonium salt is first treated with the fluoroboric acid, that is HBF4. So HBF4 is also known as a fluoroboric acid. So when they are treated with the fluoroboric acid HBF4, and the disonium fluoroborate precipitated is isolated and dry. It is then heated until it start decomposing to give the aryl fluoride product, right? So it is then heated until it start decomposing to give the aryl fluoride product. Now let's see the replacement of disonium group by the OH group. So if the copperous oxide is added to the dilute solution, in the last group we induce fluoro, right, by removing the disonium salt. So in copperous oxide is added to the dilute solution of the disonium salt containing the large excess of copper nitrate, then the disonium group is replaced by the hydroxide group. So this is also very important. When the benzene disonium sulfate is treated with the copperous oxide, they will convert it into phenol. Right. Now, next thing is that is the replacement of disonium group by a hydrogen atom. So how this takes place? So the reaction of disonium salt with the hypophosphorus acid, that is H3PO2, replaces the disonium group by the hydrogen atom. When N2Cl is treated with the H3PO2 in presence of H2 and 25 degrees Celsius, they convert this into benzene and releasing gas like N2, H3PO3 and HCl. Okay. Now the next is that is a coupling reaction. So the coupling reaction of the arene disonium salt. So arene disonium salt react with phenol and tertiary aryl amine to give azo compound, which are known azo dyes, which are also known as the azo dye, right? So this reaction is called the coupling reaction, and this one is very, very important reaction, right? So this is known as a coupling reaction. Okay, so this is how you'll get to know how this coupling reaction comes into the picture. Okay, so basically this is the coupling reaction. Okay, so in this, the arene diazonium salt is react with the phenol and the tertiary aryl amine to give the azo compound, right? Which are also known as the azo dyes. So these are the examples of the coupling reaction, as we can see here, that the BDC is react with the phenol to form this compound, right? That is called para hydroxy azobenzene. So due to this, this thing, this will known as azo. Right? So this is known as a para hydroxy azo compound. Always remember this thing, right? So this reaction is called the coupling reaction. Hence, by using the above reaction, we can synthesize a variety of azo compound. Right? So this is how will you get this all this reaction. So this is the way by how will you get the entire reaction. Now let's see some question that how we are able to solve some question related to this chapter. Right. So just to give me a 1 minute so that we can start our question session. Let's see some question related to this. Right. So the question is, the first question is, that is the conversion of benzene iodinium chloride to bromobenzene can be accomplished by, right? That is, you have to convert BDC. That is, how will you convert BDC? That is benzene diazonium chloride. That is N2Cl, benzene diazonium chloride into bromobenzene. We already discussed this thing now in bromobenzene. So the question asks, the conversion of BDC chloride to bromobenzene can be recombined by. The first option is, in the first option they are given RTM. In the second option they are given Friedel-Crafts. That is Friedel-Crafts. Friedel-Crafts reaction. And C, that is Gutterman reaction. Gutterman reaction. And in option D, they are asking about the azo coupling reaction. So which one is true, beta? That is nothing but Gutterman reaction, right? We already studied that when the BDC is treated, right? With the BDC, that is this one. When the BDC, that is N2Cl, is treated with the copper Br and HBr, right? Copper, sorry, only copper, because copper and HBr. We if you're using the Sandmeyer reaction, then we're using copper Br. In case of Gutterman, we're using only copper and HBr. Then we'll convert this into bromo, right? So this is how will you convert this, right? I hope this is clear to you. Now, the next question is, second question they are asking, the amine does not react with the acetyl chloride. The amine does not react with acetyl chloride. the amine that does not react. The amine that does not react with acetyl chloride. Right. So you have to name this the amine that does not react with the acetyl chloride. The first option is CH3NH2. The second option is CH3 twice NH. And the third option is CH3 thrice N. And the fourth option is none of these. None of these. So you have to identify, right? You have to identify in this the amine that does not react with the acetyl chloride. So which is the correct option, beta? Which amine does not react with this? Right. So we know that basically what is acetyl chloride? That is nothing but CH3, CO, and this is CO. So in this, if I'm talking about CH3 NH2, right? Or I'm talking about this one that is CH3 NH CH3, right? So these all having one hydrogen atom. So this hydrogen atom, react with this chlorine to, removal of HCl will be takes place. And the formation is like CH3. This is N. And again, this CO, CH3 and H. So this will be formed, right? So this will be formed. In case of secondary as well, we also get like this, we have a CH3, we have a N. Now this HCl will be removed. So we have, this group like CO, CH3, and this also we have a CH3. So this is possible. But in case of the tertiary amine, we don't have any hydrogen, right? In case of tertiary amine, we don't have any hydrogen. We have a three alkyl group only. So they do not have any hydrogen. So this won't react with the CH3, CO, and CO. So this won't react. So this will not react, no reaction. Right, no reaction. So the amine that does not react with acetyl chloride is nothing but that is option number C. That is tertiary amine. Right? Now, let's move to the next question. That is aniline. Aniline reacts with ozone gas and KOH to form. Right. So aniline reacts with ozone gas and KOH to form what? The first option is that is phenol. Phenol. Second option is right. The third option is right. And the fourth option is right. So aniline react with ozone gas and KOH to form what? You have to identify this. So we know that what is ozone gas formula. We know this that is aniline. Now, when the aniline is treated with CuCl2, this is the frozen gas, and KOH, what they will form? They will form like NaHCOCl, right, plus SCO. Now, again, when they are some heated because they are unstable, so they will form, right, NCO plus SCO. So D option is the correct one. So which is the correct option? That is D. So D is the absolutely correct option for this, right? Now, let's do another MCQ. Yeah. In this reaction of aniline, a color product C was obtained. The structure of C would be, you have to identify the structure of C. So what is, this is aniline. When they are treated with NaNO2 and HCl, they will form B, right? So this is A, and they are treated with NaNO2 and HCl, they will form B. Now, when B is again treated with cold, they will form C. Now, you have to identify the structure of C, right? So, you have to identify the structure of C. What is the structure of C here? Right. So, let's see. We know that when the benzene is treated with NaNO2, what B will get? So, the B will be nothing but BDC, right? That is benzene diammonium chloride. N2Cl. Now this NTCl is treated with this compound NN dimethyl aniline, right? So what they form? They form like nothing but azo compound, right? And triple bond, then double bond N, right? So this is the correct product. That is the option number D. That is a para, right? So that is known as a para dimethyl azobenzene. Para dimethyl azobenzene. So this product you will get. Right. So this is the product that you will get in this reaction. I hope this is clear to you, right? Okay. Now the next question is, when aniline is treated, this is aniline, NH2, right? So when they are treated with Br2, H2O, they will form A. Now again, this A is treated with NaNO2, HCl first, and in second, S3PO2. They will form B. You have to identify this B product, right? So you have to identify the product B. So let's see how the product B is obtained. So we know the aniline is treated Br2O. It will form 2-bromo, 2,4,6 tribromoaniline. So it will form NH2, Br, Br, Pr. That is 2,4,6 tribromoaniline. This is A. Now, when this A is treated with NaNO2, then you'll get the BDC N2Cl, Br, Br, Br. Right. Now again, when they are treated with the S3PO2, the S3PO2 remove this AO2 compound. So this will become only that is Br, here method. Right. So this is 246 tribromo benzene. Right. So this is the product that will get, that is option B. So this is the correct product. Right. So this is what you'll get in this. So this is the important question of this chapter that we'll discuss in this class. Right. So just try to revise the whole concept. Try to learn all these things that we already discussed in this chapter. Right. So that is already, that is amine, their classifications, how their method of preparation, their structure, tetrahedral, right? So there's trigonal, pyramidal, they will shape, IUPC naming, their preparation, that is from alkyl halide, you'll prepare this, or you'll prepare this from the nitrile, cyanide, amide, and nitro compounds, right? Such as the Hopman's bromide, this also play important role. Physical properties of aniline or amine, right? Solubility, their basic character, that tertiary amine is expected to be highly basic, but not true. The secondary amine is more basic than this. So why this is happening? So this all point you need to be remember this thing, right? Okay. So this is all about why aromatic amine are less basic than this. Aliphatic amine is more basic than ammonia, and ammonia is more basic than the aromatic amine. So this all thing you need to remember in this, right? Generally, for the halogenation and nitration, how will you get this thing? Sulfonation. How will you identify the primary, secondary, and the tertiary amine? Isonium salt and their preparation and their conversion related to this, right? So these all are the very, very important thing, how hydro compound will be formed, right? So this is all in today class. So just revise this thing. We meet in the next class where we'll discuss about the biomolecules and all. So till you just revise this all these things so that you can able to solve question, right? Goodbye.